we're going to peel back a layer. Look at something you use constantly without maybe thinking about it. We're diving into SQL.
Yeah, the language of data. We got a really good look at the day one materials from a SQL Mastery series. Slides, scripts, the whole outline. It's a solid foundation.
Right. And our goal here is basically to cut through, grab the essentials from this material, and get you up to speed fast on what SQL is and how it works with relational databases.
Yep. Get you informed on the basics that will power so much stuff.
So what we'll cover is what SQL actually does, how data gets organized in these database systems, and then the absolute key commands you need for like everyday data tasks.
And it might seem simple, but we'll also hit those really common pitfalls, the mistakes you definitely want to avoid.
Okay, sounds good. Let's jump right in. The language itself. What is SQL?
So SQL, it stands for Structured Query Language. The main idea is it's the standard language, the way you talk to relational databases. Think of it less like a complex programming language and more like specific instructions.
Instructions for a very organized data manager.
Exactly. It's how you ask questions or tell it what to do.
So it's like the universal translator for data.
Pretty much. And that's huge. The source really stresses this. You learn SQL, and whether you're using MySQL, PostgreSQL, SQL Server, whatever, the basic commands are mostly the same.
Learn it once, use it lots of places.
Right. Huge advantage.
Which makes it, well, super valuable for a lot of jobs, right?
Oh, absolutely. It's not just for database folks or back-end developers. Analysts, BI people, data scientists, they all need to pull data. SQL is often how you do that first step.
If you touch data, you probably need SQL.
Chances are, yeah.
The source had that analogy, the librarian one.
Ah, yeah, I like that. The database is the library, data is the books. SQL is how you specifically ask the librarian, the database system, find this book, add this new one, fix this card, remove that book.
Okay, got it. It's the instruction set for managing the collection.
Perfectly put.
So SQL is the language. Where does the data actually live? How's it set up? Relational databases.
Right. So a relational database is all about structure and, well, relationships. The main place data hangs out is in tables. And yeah, visualizing them like spreadsheets works really well. Rows and columns.
Tables are like the sheets in Excel, kind of.
Exactly. And then a row, sometimes called a record, that's one complete entry, like all the info for one customer.
And a column or field.
That's one specific piece of info within that row. First name, email, zip code, whatever.
Okay. And the source mentions the primary key being super important.
It is absolutely critical. You need a way to uniquely pick out one specific row. That's the primary key. It's a column, sometimes two, that guarantees no two rows have the same identifier, like a customer ID or a product SKU.
So you can point to that one thing precisely.
Without ambiguity. Yes.
And relationships. That's the relational part, I guess.
That's the magic. Tables don't just sit there alone. They link up. Usually you use the primary key from one table, like customered from the customers table.
And put it in another table, like orders.
Exactly. It becomes a foreign key in the orders table. So you don't need to copy the customer's address into every single order they place. You just link back to their main record using the ID.
Ah, avoids repeating yourself and keeps things consistent.
Spot on. Saves space, prevents errors.
The source had that nice customers table example.
Okay.
Customer, first name, last name, email as columns.
Yeah, and then rows with actual data like John Smith, john.smith at example.com makes it concrete. You see how the columns define the structure and the rows hold the individual entries.
And it mentioned the bigger picture too. Databases containing tables, schemas.
Right. Quick overview. The database is the main container. Schemas are like blueprints, grouping related tables. Indexes help speed up finding data, like a book index. And constraints are rules like making sure an email looks like an email or a price isn't negative. They keep the data clean and structured.
Okay, got the language, the organized storage, relational databases. How do we actually use it? The big four.
The big four, yeah. It boils down to four basic actions you do with data. It's called CRUD, C-R-U-D, create, read, update, delete.
Simple enough.
And the really key insight from the source, these four things make up something like 90% of what databases do day to day in apps and businesses.
Wow, 90%. Just those four actions.
Pretty much. Signing up, viewing your profile, changing your settings, buying something, deleting a post, it nearly always maps back to one of these two RUD operations happening with SQL commands.
So mastering these gives you massive leverage. What are the SQL commands for CRUD?
Okay, so create uses insert, read uses select, update uses update, delete uses delete.
Got it. Let's start with read. Select. The source says it's maybe the most important.
Often, yeah. Because it's how you ask questions, how you retrieve data. It's your main way of looking inside the database.
And the basic structure seems straightforward.
It is. Select column 1, column 2 from table name. You say what columns you want and where they are.
The source had examples like getting absolutely everything.
Right, using the asterisk, the select from customers just means show me all columns from the customers table. Quick for exploring.
But usually you want specifics.
Usually, yeah. Select first name, last name from customers. Just gives you those 2 columns. Much cleaner if that's all you need.
And you can filter which rows you get to with where.
Now select gets really useful. Select from customers where city, New York. This isn't just choosing columns, it's choosing rows that match a condition. Only show me customers from New York.
The where clause is key for targeting.
Absolutely fundamental. We'll see it again.
And those technical points. Semicolons. Case sensitivity.
Little details, but important. SQL commands with a semicolon. It tells the database, okay, I'm done with this command.
Add case.
SQL keywords like select, from, we're usually case insensitive. Select is the same as select, but convention is uppercase for readability. However,
To the data itself.
the data itself often is case sensitive. So if the city is stored as New York, searching where city New York might not find it, you gotta match the data's case.
Good tip. Okay, reading is select. Adding new stuff.
That's insert. For creating new records, new rows.
The syntax looked like insert into table name. Column 1, column 2, values,
Yeah.
value 1, value 2.
Yep. Point to the table, list the columns you're filling, then list the values in the same order.
Like adding 1 employee.
Insert into employees, first name, last name, department, values, Alice Williams marketing. You're very specific about what goes where.
And you can do multiple at once.
Yeah, the source showed that. You just list multiple sets of values after the values keyword, each in parentheses, separated by commas. Saves time for bulk inserts.
Best practices for insert.
Always list the column names. Don't rely on the default order. Makes it readable, less likely to break if the table changes. And make sure your data types match. Don't put text where a number should go.
Oh, and the quotes.
Right. Use single quotes around text values like Alice or marketing. That's standard SQL.
Single quotes for text. Got it. What about changing existing data?
That's update. Modifying records already there. Fix a typo, change an address, update a price.
Syntax. Update table name set column 1 equals value 1 where condition.
Exactly. Specify the table, use set for the changes, and then the absolutely crucial part, the where clause.
Okay, here comes that critical warning again from the source.
This is the big one. For update, if you forget where, if you just say update customer set city, Miami, it will try to change the city to Miami for every single customer in the table. Every single one.
Yikes. That's bad.
Understatement. So the where clause targets only the row or rows you actually mean to change.
Like where customer equals 123.
Precisely. Update product set quantity with productipia or productify. Changes only product 5. The where is your safety net and your focus beam.
Absolutely vital.
Okay.
And the last of the big 4, getting rid of data.
That's delete. Removing rows, records from a table.
Syntax. Delete from table name where condition.
Right. You say what table to delete from, and again, you use where to specify which records should go.
Like deleting old orders.
Yeah.
Where status canceled.
Exactly. Or the source showed using multiple conditions, like where sign update some date and status inactive, deleting records that meet both criteria.
And I bet we get a critical warning one more time here.
You bet correctly. Just as important, maybe even more so, always use where with delete.
And if you don't.
Delete from customers with no where clause.
Yeah.
Tries to delete every single record in the customers table, just gone, wiped clean. Trying to remove one test user and accidentally emptying the whole thing.
Catastrophic is the word. Okay, message received loud and clear. Where is non-negotiable for update and delete?
It's the difference between careful editing and setting the whole manuscript on fire.
Okay. The source ties this all together with that online store example. Seeing them in sequence helps.
It does. You might start with select from customers to see who's there.
Then someone new signs up.
Insert into customers values. Mike Brown adds Mike as a new row.
Then maybe Mike moves.
Needs an update. Update customers set city Miami, where customer is 1, assuming Mike is customer 1, only changes his record.
And finally, maybe clean out old inactive accounts.
That's delete from customers where status inactive. Removes just those rows. Shows the flow of how these commands work together constantly.
Really drives home how these 4 are the workhorses. The source also had practice questions, which seem essential.
Oh, you have to practice. Trying to insert, update, delete it makes you use the syntax, think about the data types, and hopefully drum into your head the need for where.
And it highlighted other common beginner mistakes too, beyond just where.
Yeah, besides the big where warning, forgetting semicolons at the end of statements, easy mistake causes errors.
Quote confusion.
Definitely. Mixing up single quotes and double quotes. Standard SQL uses single quotes for text data like New York. Stick to that for values.
Case sensitivity in the actual data.
Right. Select is usually case insensitive, but where city, Boston might fail if the data is stored as Boston. Match your data's case.
And skipping column names in insert.
People try insert into table values, val1, val2, val3, to save typing. But you must provide a value for every column in the table's exact order. If the table changes later, or you miss one, boom, error. Listing columns, insert into table, col1, col3 values, val1, val3, is safer and clearer.
Good practical advice. And those pro tips, backups.
Always a good idea before major changes, especially big updates or deletes. And the other big one, test your where clause with select first.
How does that work?
Before you run, say, delete from users, where last login 2023-01-01, first run, select from users, where last login 2023-001-011, look at the results. Is that exactly who you want to delete?
You preview the rows that would be affected.
Exactly. If the select shows the wrong rows or too many, fix your where clause before you run the dangerous delete. It's a simple check that prevents disasters.
Brilliant. That's a lifesaver. And using meaningful names.
Just good practice. Customers is easier to understand than CRUD BLV2. Makes writing and reading queries much less painful.
Okay, so let's zoom out. What are the key takeaways from this deep dive?
We've covered the real basics. SQL is the standard language for relational databases. Data lives in tables organized with rows, columns, keys, and relationships. And the core actions are CRUD, create, insert, read, select, update, update, delete, delete.
And we hammered home the importance of the where clause for targeting update and delete safely. These really are the fundamental building blocks for how we interact with data systems.
Absolutely. And the source material makes clear this is just day one. Next steps usually involve more advanced selects, better filtering, sorting results, limiting them, combining conditions. It gets more powerful from here.
So how can you, the listener, keep exploring?
Get hands-on. Use an online SQL editor. Find sample databases. The source likely points to resources. Type these commands, run the examples, try the practice problems. You learn SQL by doing SQL.
And it's kind of wild when you stop and think about it, isn't it?
How so?
Just how these 4 simple commands, select, insert, update, delete, really underpin almost everything you do online.
Yeah, think about it. Posting on social media, that's probably an insert or maybe update. Checking your bank account, select. Changing your profile picture, update. Deleting an email, delete.
It's incredible that so much complexity runs on these foundational actions.
The ability to manage and manipulate vast amounts of information rests on these, well, relatively straightforward interactions.
Makes you think, doesn't it? What does it say about the structure of our digital world that these simple operations hold so much power? Something to chew on.
Definitely something to think about.
All right, that wraps up our deep dive into SQL basics. I hope this gives you a solid, informed starting point.
Please subscribe, like, and share. Thank you for your support.